Okay, so today we're going to go over chapter 12, section 1. You will need a calculator. And I guess here's the examples. It's called analyzing data. So we're going to look at a bunch of data and determine which model is best to represent the data. We'll look at linear models, quadratics, and exponentials. We're not going to really do cubic and quartics this year. So we're just looking at linear, quadratic, or exponential. So let's try some examples. Number one, use the scatter plot below, so check out these dots, to determine which of the following equations would be most appropriate as a linear model. So notice how all of these are linear equations. So now we need to pick which equation is best and explain why we think that one is the best. So here are your options. Positive 4.5x plus 88.17. Negative 4.5x plus 88.17. And then the last one is positive 2.09x minus 1.34. So out of all those, the only logical one for a linear model is going to be B, because that's the only equation with a negative slope. B must have a negative slope. On your quiz next week, it's going to be multiple choice. And most of them, you're just going to be selecting the correct model. You don't have to explain it. But on the ones that are free response, for those, you will have to explain it. It will ask you, explain why. So in this case, we would have to pick the one with the negative slope. That was number one. Let me know if you have any questions. Let's keep trying. Number two. Analyze the data shown in the scatter plot and determine which of the equations best models this data. Because the points form like a negative parabola, it must be a negative x squared. We know it's not B. So A must be negative. Like ax squared, A must be negative. Next, we can take a look at the value of the y-intercept. So let me write down the equation for you. For the it's right here. For the quadratic equations, ax squared plus bx plus c. A determines whether the parabola opens down for negatives or up for positive. C is the y-intercept. So based on this data, the y-intercept should also be negative. So that would only leave us with option A. So again, on the quiz, you're mainly just determining which one is the best model, but for the free response, explain. Let's try it again. Number 3. Analyze the data shown in the table here. Which of the following equations would be most appropriate to use for the exponential model? I think for this one, since it's a table, what I would like to do is I would like to graph it and look at a scatter plot. And then the calculator, once you graph this data, the calculator will give you an equation. So it's called exponential regression. So at this point, you need a calculator. I'm going to be using the Desmos online calculator, which is available to everyone. Desmos. We need a graphing calculator. So we're going to click on graphing. The directions that I'm about to go over, you can find a document explaining to you how to do this. And that document is on the in Schoology. It tells you here how to do Desmos linear regression, quadratic regression, or exponential regression. So I'm going to follow these directions right now. The Desmos exponential regression. If you rather use your Inspire, you have to follow these directions. Okay, so if we follow the directions on there, it first says you need to click the plus sign to add a table. Now we're going to have to type in our data into this table. So number 3, the data is 1, 2, 3. Okay. Give you a minute to type all that up. No! I typed in something wrong. Oh, I skipped 4 here. Gosh darn it. Okay. No one said anything. Okay, now I hope I typed everything. Question, Pritam?
Hi, yeah. How do we do the table again? Sorry, I think I missed it.
You need to go to a graphing calculator. So I don't want to get out of there. First, go to the decimals.com.
Yeah.
Then you need to click on graphing calculator. And then there's a little plus sign here on the left corner. Click that. And then you can click on the one that says table.
Okay.
You found it?
You.
Okay.
Yeah.
And again, everything that I'm doing right now is there's a document here that has the directions. So this is the document. It tells you exactly what to do. Because it's the first time using this program, even for me. So I need to look at the directions. But you need to practice that before the quiz next week. Okay. So now that I've typed it up, now that I've typed it up, I need to be able to see those dots on the scatter plot. So let me just read the directions. It says, enter the data. Okay, I've done it. Now you need to use the plus or minus sign buttons on the top right to be able to zoom in and out. So on the right of the screen, there's a little plus and the minus button. Let's click plus so we can zoom in. Nope. Let's click minus so we can zoom out. There we go. Minus to zoom out. Okay. That looks decent. So I click the minus sign to zoom out so I can see the little dots. So that they do look like an exponential. Now I just need to figure out like what's the equation. So to figure out the equation, we're gonna follow the steps that are on Schoology. This is the Word the document. So it says use the plus or minus buttons to zoom. We already did that. You can also drag your screen over and adjust. Okay, we already did that. Okay, after we've entered the data, now we need to go to box 2 and type in the following stuff here to we have to type it exactly as we see it here to actually get the equation. So we're gonna go to box 2 and type y1, little squiggly symbol, a times b raised to the x1. So let's try that. So first we need to go to box 2. Find box 2. Click on it. Now we need to type in y1. Sure. Now the squiggly symbol. It took me forever the other day to find it, but it's on your keyboard somewhere next to the number 1. Shift symbol. Find that. Prism, do you have another question, or did we forget to lower your hand?
Sorry, I forgot to lower.
All right, lower. All right, so find the squiggly symbol. Y1, squiggly symbol, A, parentheses B, raised, so raised. I think you can do shift plus and it erases it, or you can do the caret symbol thing. Raised to the x1. Raised to the x1. Click on log mode. Click on log mode. Okay. And now we should be able to see the equation. And we want to know which of the following one is most appropriate. So based on this analysis here, it looks like A is about 11,776 and B is 0.56. So now we just want to look at our notes and see which one's the closest or which one's best. So I think the best one or closest one would be letter C. The ones that I have on your quiz are more exact. So this is just an approximate one, but this is the one that's closest to what we just got. So 0.56 is the B. So many windows open. 11,776 is the A. So yeah, we're gonna go with C. Explain. We can just say we use the exponential regression on the calculator. Used exponential regression on calculator. Okay, we're going to keep practicing this when we get to the back. That was number 3. Number 4 says use the scatter plot. Which of the following equations is most appropriate? So for that one, it's not going to be B because since this function is what we call like decay, the B value has to be a fraction. It has to be between 0 and 1. So it can't be 1.28 because that would be a growth. That one would look like that. So it's either A or C. It's probably not A because that has a negative in front of it. That would reflect it like that. So C is the only reasonable one, because C is the only one that would look like a decay like that. And you can also always confirm with the calculator. You can go to your calculator and graph all three of these if you wanted to, and see which one looks like that. But this one, C is the only option, since B is between 0 and 1, and the A value is positive. So those were just analyzing the data to pick the best model. You will have some of those as multiple choice, and then one for response where you have to explain why you picked it. So practice these on the homework tonight. If you want more practice, Math Excel homework, do it for practice. Now we do more. On the back it says, use differences or ratios to determine the type of function that would best model the data. So we've done differences before. So let me remind you how differences work. You look at the difference in the y values and you see when they are constant, like when are they the same. So for example, the difference from a 0 down to a 0.25, it's a negative 0.25. It's going down. The difference from negative 0.25 to a negative 1 is going down by 0.75. So right now, this is not going to be linear because those differences are not constant already. They're not the same. So it's not going to be linear. But let's keep going. The difference between negative 1 to negative 2.5 is negative 1.25. And then one more time. From negative 2.25 down to a negative 4, that's negative 1.75. Okay, so it's definitely not linear. Okay, now let's see if it's quadratic. So we're going to find the differences in the y values again, the differences in these differences. That's called differences. From negative 0.2 to negative 0.5, it's, oh no, from negative 0.2 to negative 0.7, negative 0.5. From negative 0.75, negative 1.25, negative 0.5. Then that's negative 0.5. Okay, so because these differences are all the same, it means that this model is a quadratic model. Quadratic model. Now that we know that it is quadratic, we need to find the equation, and we can just find it on the calculator using quadratic regression. So let's use the Desmos calculator to figure out quadratic regression. So first, pull up these quadratic regression notes. So pull those up. And here's what we're going to do. We're going to go to the Desmos calculator. We're going to pick graphing calculator. We're going to add a table. We're going to type in our x and y values. So let's just start doing that. Can I just do it here? Yes, okay. Table. So I'm doing number 5. I'm typing in those numbers. Now I want to, oh, here they are. We don't really need the scatter plot. We just need to actually find the equation. So to find the equation, go to box 2 and type in this mess. Y1, squiggly symbol. I'm sure it has a name. If anybody knows it, you can educate me. But okay, squiggly symbol, A times x to the 1 times x1 raised to the second plus bx1 plus c. So that's what we're going to type in on our box 2. Y1. Squiggly symbol. Parentheses, ax1. ax1 raised to the second. Tiled. I don't even know how to pronounce that, Kyle, but thank you. Plus b x1. Let's see. All that work for that. So if you correctly type everything that is on those directions, you gotta practice. Like I'm practicing because I've never used this decimal stuff before. I always use my actual graphing calculator, but not everybody has one at home. So it's pronounced tilde? No, tilde? Tilde? I can't read pronunciations. I blame it on my English language learner. But anyway, we're just going to go with it. Thanks. So it looks like number 5, the equation is just going to be y equals a, so negative 0.25 x squared plus 0 plus 0. So that should be the equation, which is all that work. We could have probably just done it faster by hand. So y equals negative 0.25 x squared. Okay, so that was a lot. Now let's just keep practicing on the other ones. I don't think I'm going to do all the other ones all the way, but let's just keep practicing. So number 6, let's do the same thing. Let's try differences in ratios. I'll show you what the ratios mean. Okay. Well, number 6 is really quick because it's linear, so let's just do it. So this one, 94. 94. 94. Okay, that's linear. Okay, that one's going to be just faster if we just do it by hand probably and try to do the linear regression. Because obviously the slope is -4. And the y-intercept is -3. Much faster. So that we just did it by hand. If it's not exact or perfect, then you do want to do the linear regression on the decimals calculator. And again, there's some directions on here how to do the linear regression, but it's the same kind of thing as the exponential and quadratic, but now you just have to change it to a linear function here. Practice it. Let me try to get to one where it's ratios. Number 7. So let's try to see differences. So the differences are only going to tell you if something is linear or quadratic. Linear, quadratic, or maybe cubic. We're not really doing cubics this year, so mainly just linear or quadratic for the differences. The ratios are going to tell you if it's exponential. So for example, number 7. We can try to do the differences first to see if it is linear or quadratic, but it won't be. So from 0.5 to 1, that's 0.5. From 1 to 2, that's 1. From 2 to 4, that's 2. From 4 to 8, that's 4. So you can kind of see, it's not linear for sure. You can kind of see they're increasing by like times 2, times 2, times 2, times 2. Like those y values, that's called the ratio. But let's just, process of elimination is not linear. Okay, it's also not quadratic. So then what we're going to do is it's going to be exponential. And here's how you prove that it is exponential. You do the ratios. So instead of looking at the difference from the y value to the next, you look at the quotient. So you can, so for example, from 0.5 to 1, what I like to do is, let's go to the ratios. I like to divide the y value by the previous one. So that's a ratio of 2. And then you do it again. The next one is 2 over 1. That's the ratio of 2. The next one is 4 over 2. That's a ratio of 2. The last one is 8 over 4. That's a ratio of 2. So that is a constant ratio. So when you have a constant ratio, that would be exponential. Make sure you know like that vocabulary because you'll see those as multiple choice. So exponential functions have a constant ratio. The linear or quadratics have constant differences. So for this one, we could type it into the calculator again like I did for the quadratic model, but because the ratio is just 2 to the x, here's the equation. It's just going to be y equals 2 to the x. Like a times b to the x. So just to save us time for now, it's just 2 to the x because that was the constant ratio. For the sake of time, I'm going to skip number 8. You can do it for practice, but that one, or you can just skip it all the way because that one is a cubic and we're not doing cubics this year. We're only going to be doing linear, quadratic, or exponential. So for now, I guess let's just skip number 8 all the way. Okay, now let's keep trying. Numbers 9 through 13. We're going to have to take all this data and look at a scatter plot. The R-square value, which tells you how good the model is, you want it to be closest to 1. And then in the situation to determine which of the linear, quadratic, or exponential functions is best. So I guess let's start with the first one. We need to take this data here, type it into the calculator to see a scatter plot. So here goes decimals again. Okay, type in those numbers. Whoops. We could also, I'm just thinking instead of putting it in terms of like 2000, 2002, that's fine. You can do that. That would be okay. And your answer will still be correct. But I think we can just do like 0, 2, 4, 6, 8, 10 instead. Either one's correct. Your answer is going to be slightly different, but I think on that answer key, I have both correct answers. So let me go with 0, 2, 4, 6, 8, 10 instead of 2000, 2002, 2004. And now this is going to be perfect. I typed everything right. Here we can click the plus or the minus to zoom in or zoom out. We can also adjust the window. I mean, that's pretty good right there. And that looks exponential, so we're going to do exponential model. But with the plus and the minus, you can zoom in and zoom out to find a better view of the scatter plot. Or just like on the Inspires, you can click on this graph setting tool picture. And you can pick your own window for the x-axis. Like we can say -10 to 20. And then for the y-axis, same thing. We can say -10 to 50. And it changes the window to that. So here's the window still. Anyway, the scatter plot definitely does not look linear, so we're not going to do a linear model. It looks exponential, so we're going to do an exponential model. And then we could do a quadratic to see if a quadratic one would be better also, but no, exponential is the best model. So let's do an exponential model. Here, follow the directions as to how to do an exponential model. We are going to type y1. Tilde. Symbol. A times b raised to the x1. And here's what we need to look at. We looked at the scatter plot and it clearly looked exponential. Now we want to look at this r-squared value. The highest the r-squared value can be is 1. And that just means that this is a perfect, exact exponential model because r-squared is equal to 1. If it's not equal to 1, like it can, I don't know, like if it's 0.1 or 0.5 or even like 0.6, something small like that, then it wouldn't be a good model. But 1 is really good. Anything like 0.9 or higher is going to be a very good r-squared value. So it matches the data perfectly. And now we just need to copy this a value and b and write it as an equation. So your equation will be, oh, I forgot to click the log mode. That matters. So please make sure you do click this log mode if you're using this or when you use this on your quiz, because it changes these values slightly different. I don't know what it does with the system, but make sure you click this log mode. So here's our equation. It's going to be y equals 0.036 times 2.016 raised to the x power. So that's what I'm going to write down on my paper. I'm going to write down exponential because scatter plot, because we looked at the scatter plot and r-squared was equal to 1. On the first response, it's going to ask you to justify which model you use. Like, why did you pick that one? And you're going to have to tell me because the scatter plot and because of your r-squared value was the highest. This one's the highest. So what did I just say? A was 0.036. B was 2.01 something. I don't know. Let's round to 7. These are just going to be multiple choice, so just pick the one that's rounded or closest to it. And that's the model for number 9, exponential. Let's try number 10 and check it out. Okay, let's do another one. Oh, number 9, if you did do it slightly different, like if you actually use like 2000, 2002, 2004, your answer will be slightly different. It'll have the same b value, but this a value is like something crazy, like 2.1 times 10 to the negative 600 something. But they're multiple choice, so I guess this is the one that you would choose. So change that to 0, 2, 4, 6, 8, 10. Okay, let's try another one. Number 10. What is this? Year and income. Okay, we're gonna type in this data into a calculator, into this table. Hello. Okay. That looks linear. Okay, I mean, those little dots, they don't look exponential. They don't look quadratic either. They look linear. But if we're not sure, we can check the R-squared value on all the models to see which one's best. But that one looks linear. So let's try to see. Let's try to see the R-squared value in the linear model. So follow the directions on the linear model Desmos. Let me look at them. It says, type in your data. We already did. Go to box 2. We're going to be doing the y1 tilde symbol, mx1 plus b. So that's what we're going to type. Okay. Y1. M x1 plus b. Okay. So it's not perfectly linear because if you look at the R-squared value, it's not 1, it's 0.998. That's still pretty close to 1. So the linear model looks decent. I'll probably go with the linear model, but let me just check. I always just like to check the quadratic and the exponential models to see if they would have like a stronger R-squared value. So let's try the quadratic. Y1. Quadratic was a x1 squared plus b x1 plus c. Okay, so the little black line right here, that's a quadratic model, and it looks like it fits the dots a little better just because, like a little better, because the R-squared value is 0.999 instead of the 0.998. So that's why you do have to look at the scatter plot and at the R-squared values for these. So between the linear model and the quadratic model, I am now going to go with the quadratic model because the R-squared value is bigger than for the linear R-squared value. 0.998 versus 0.999, almost 1. We could try the exponential to see if it's any better, but I don't think it will be. But we can just try just to see. One. Oops. A, B, raise. Make sure you practice this Desmos thing before the quiz next week because you need to do it a little bit faster. If not, you're going to run out of time. Change it to lock mode always. I mean, it's the red graph. The R-squared value is 0.999. I'm still going to go ahead and go with the quadratic, 0.99995. That's the largest R-squared value. So let me copy this equation A, B, C as my final answer. So I'm going to go with quadratic because I have the highest R-squared value. Y equals. You can round to whatever the quiz says, but I think these are multiple choice, so you just have to match the answer that's closest to the rounded numbers. 0.0, A was 0.014, I guess, x squared. Plus, what was the other one? B was 0.423. 0.423. And then C was like 18 something. 18.289. Yeah. The equations are multiple choice, so just select the one that's closest to it. Yeah, that looks right. And I'm just gonna keep practicing these. So in order to do these, you need to graph your data. You need to look at the scatter plot. You need to look at the R-squared value and see which one has the highest R-squared value closest to 1. And you also sometimes need to analyze the situation. I'll tell you what that means. Number 11. Do we have time? Sure, we got time. Let's try number 11. Take these dots, put them in the calculator. Figure out how to do this. If you do have your own personal graphing calculator, you need to follow the directions that are on the Inspire for you to do all this. Or you can just use a Desmos calculator online. Number 11. Leave all these things there, and let's just change the table. I think if we leave on the Desmos, if we just leave the stuff there, it might automatically calculate it for us once we change the table. So let's try it. Number 11. Type in 0, 2, 4, 6, 8, 10. 2, 9. And I hope this whole thing is recording. 4.2. 5. And I'm definitely gonna have to change this window, either zoom out. Nope, so zoom out. Or let me just change the Y maximum. This Y maximum's gotta be at least more than 1,000. Let's put like 1,500. Anyway, so on this one, clearly, like, we're not going to do the linear model nor the quadratic, because if you notice, the exponential model is the one that fits it best. So it's definitely exponential. You can confirm that by looking at those R-squared values. So for the linear, the R-squared value was only 0.6, so that's not even close to 1. The quadratic R-squared value was 0.92, but clearly, for sure, the exponential R-squared value was 0.99993. So that's the best model. So that's the one I'm going to choose. So number 11, the exponential model is the best because the scatter plot looks linear, looks exponential, and the R-squared value is the highest. So now we just got to copy this y equals a b to the x onto our paper. So exponential, because scatter plot and R-squared value. So it was y equals 1.085 times 1.977x. So that's number 11. You just got to practice these, do your math Excel homework. I'm going to skip 12 because we don't have enough time to do it, but you should try number 12 by yourself. Do the same thing I've been doing. Check the answer key. It looks like number 12. The scatter plot looks quadratic, like it goes up and down, quadratic. So for number 12, the quadratic model will be the best. So then just do quadratic regression. I want to skip to 13 because that one you definitely need to know for your quiz and possible test. 13. Same situation. We are going to, because we're supposed to be analyzing the situation on all of these. So for example, on number 13, the following data represents the number of hours and the battery life of a cell phone after it's being charged. So as the number of hours increase after it's being charged, the battery life is decreasing. So first of all, let's go plot that and see what kind of model looks best. Linear, quadratic, exponential. Leave those there. Let's fix this. Delete. 3, 7, 9. 86. Let's fix this window. Zoom in? No. Let me just change this Y max. We don't need 600. We probably just need like 100 for the Y max. So Y, let's change it. -10 to 100. That's better. Okay, so let's look at this mess. It looks like the linear model is not the best because that doesn't even go through any of the dots. So the linear model, although it's like 0.955, that's just not the best model. So now we got to go with either the exponential model, which is the red one here. It has a 0.9992. So that's definitely better than the linear. And then the other option is the quadratic model. But this is why I wanted to show you this one. So the quadratic model, it has the highest R-squared value. It has 0.9998. So that's higher than the exponential. But although the quadratic is the highest R-squared value, we're not going to go with that one because it's not possible for this data to model a quadratic because the data represents the battery life of a cell phone after it's being charged. So the longer the time goes by, the less battery there will be in the cell phone, which means the exponential model just tells you that it's going to get closer and closer to zero until your cell phone dies. The quadratic model, if you pick that one, it somehow just says that magically, without charging your phone, the battery is going to come back up. Like the battery life is going to come back up. And that's not possible. That ain't going to happen. So we're not going to go with the quadratic model, although it did have the highest R-squared value. We're going to go with the exponential model because the R-squared is still pretty strong. And just because I just said, the battery life is going to keep dying until it reaches zero, just like this exponential model shows. So let's copy this exponential model. So exponential. Because the battery is going to keep dying. Until it reaches zero. So it's 0%. So again, it's just going to look exponential. It's not going to do quadratic. It's not going to come back up. not quadratic. So the model for the exponential was y equals 100, I don't know, 100 point, let's just go with 100.2 times 0.918x. Okay, so I did 100.2 times 0.918 raised to the x, and that was the exponential model, which was the best one based on the situation. And now you just got to go practice your math Excel homework for optional practice. Definitely practice this decimals calculator or even your own graphing calculator to prepare for the quiz next week. The directions are here if you're using a graphing calculator, but play around with this till you become more efficient and faster, or you're going to run out of time on the quiz. But that was it. Let me stop the video.